I think it'll be really helpful for us to revisit the networking stack briefly before we start getting too deep into things. We've got these two different models, and they're literally just models. They're not exactly concrete ideas about how things are exactly going to be in the real world. One is the OSI model, and the other one is the TCP/IP stack, also known as the DoD model. So things get a little bit sort of blurry around the top three of the OSI model: session, presentation, and application, because it really depends on the perspective you take on what's actually happening under the bonnet. So an example of this might be something like SSH. While SSH is technically speaking an application and an application level protocol or application level interaction with the system, you're effectively creating connections between transport layers on remote machines that then are reassembled at some point that are used by other services at that layer. So it really depends on where you want to look at the perspective of it. So it's a model. It isn't exactly everything set in concrete. But these two models here are exactly the same thing. They're two representations of the exact same thing. So don't be confused. They're not two different things. They're the exact same underlying technology. What we'll do now is quickly breeze through each of the different parts of the network stack. And we'll start at the bottom of the physical layer. So the bottom of the stack, this is probably a better way to look at it over here on the right-hand side. The bottom of the stack is the physical layer, and layer one, which is all of the things that you can see and touch. So that's cables, fiber optics, hardware, all of that type of thing. Layer two, as we come down, the data link layer, is how the data sort of interacts with the hardware. And we also use MAC addresses at this layer to be able to, for the systems to interact with each other. There's the hardware address or the MAC address. There are some abstractions in the middle here. There's layer 2.5. We're just going to skip right past that to layer 3. And we've got the networking layer, which is where the routing protocols are, ARP and ICMP, and also where we get IP addresses. IP addresses exist at layer 3. And then we're going to go down to layer 4. Layer 4 is the transport layer, and it provides us with a connection between hosts and flow control. And this is where TCP and the UDP live in this level right here. Layer 5 is the session layer, and this is where we get to have authentication and authorization and how we get a connection that persists when we have a login to a service or a system somewhere else. When we go back there after closing a window, for example, we're remembered. This is where that is taken care of at layer 5 in the session layer. Layer 6 is everything to do with encryption reassembly. This is TLS and SSL, and then layer 7 at the bottom. But the top of the stack is the application layer, where you get to what you get to look at on the screen when you're interacting with your computer system, which is things like HTTPS. DNS is also included here. All the mail protocols, SSH is at layer 7. So now that we've gone over that, we'll come back to ICMP. So ICMP is a layer 3 protocol, and it doesn't have network ports. So the networking layer doesn't have ports associated with it. Ports are a layer 4 idea that exists only on layer 4. So we don't deal with ports at layer 3. It's purely IP addresses. So from that point, with all of that said, we can now move across to the AWS VPC quickly, and we'll take a look at my network access control list here. And we're just going to jump right into the public zone of this particular network access control list. And you can see here the first rule I've got is an allow all ICMP IPv4 traffic, but only within my VPC. So you won't be able to get any idea about enumeration of hosts or testing connections with any machines that I might bring up on my account unless you are also within the VPC. So that won't be allowed. The ICMP protocol is broken out into a whole bunch of other things. What we're going to do is jump in here and edit this protocol. And we're going to change from all ICMP IPv4 to custom ICMP IPv4, where we get a protocol list on the right-hand side here, and we can open this up and see all the protocols that are available to us from within ICMP, the protocol itself. So the one that we're going to be interested in the most, or the couple of them, is going to be the echo reply and the traceroute. So those two things are going to be two of the main things we're going to be looking at in this lesson. But there are a bunch of other things that ICMP can offer you, depending on what your use cases are. I'm just going to cancel out of this now because I don't want to introduce any drifts onto my account. So now that we've gone over ICMP and we understand where that fits in the networking stack, and we're going to now quickly touch on ping. So ping, like every other thing on your computer, is an application. So if you want to know where ping is, ping exists on a Mac at, if we go to ls sbin, we can see in sbin, ping is an application that sits in here. There's also a bin folder, binary folder, which has most of the other applications that you know about in Bash. That's a bit of an aside, but so what we're going to do is if we want to know how something works and we want to try and work out how that thing does its business or how we can interact with it, we can use the man page. So if we type in man followed by the application name, and that could be any of those applications we just saw, we can type in man ping, and it will show us a nice output of how we can interact with this. And with the down arrow, we can scroll down and we can see some of the different options we've got here. So I can use the -C for count and then provide it with a number, and we can just send that amount of pings across the network. And we can also use something like, for example, the -F flag and flood pings across the network. And it shows you a bit of a blog about what that entails as well. And we can scroll all the way down and see all the different things that we can do for us. Oftentimes the man page will show you at the bottom some examples as well. But I think that may not be the case in ping. Yeah, there's no examples here. But so to exit a man page, we just press Q. So to use ping, for example, here, I'm going to use the Google servers. And what I'll do is I'll ping -C 4, and then I'll do 8.8.8.8, and we'll press enter, and it sends out 4 pings because we asked for a count of 4, and it exits. If we don't provide a -C and a 4, this will just keep on pinging until you do a Control-C to stop it. And that way we can see if there's a connection between these 2 points, and we can see that there is a connection. And what this tells us is it's sent 64 bytes, and we can see the sequence number, which order that it's been sent out in. The time to live is 119, and the round trip time to get there and back was this many milliseconds. So that's cool. And we've got some averages down the bottom here as well. Okay, so that's ping. So now that we've covered ping, the next thing we might want to know about is which way is our traffic taking to get to a specific destination. So if you want to know something about what way our traffic is going through the intermediate routers between our machine and the remote machine, we can use something called Traceroute. And we'll hit the Google servers again for this one. And we'll just use the 4 8s and then press enter. And it will basically, how this works is it uses something like the way that ping works. It has a system where it has a time to live of 1 for the first packet that goes out, and it basically is going to ping towards that address with a TTL of 1. It goes as far as my local router, and then the TTL expires, and then it returns with the timings for each of those things, and then it sets the TTL to 2. And it only makes it to the building router, wherever that might be. And this will be the supplier, the TPG building router. And after 2 hops, it gets as far as that, and it returns after 19 milliseconds. And you can average these together. This is 1, 2, and 3 tries. And then same again, we increase the TTL 1 by 1, and we test it 3 times as we go. Sometimes you get to things here where there isn't exactly a full connection. I'm not really a traceroute expert on this, but we get to a point where there's different parts of the way that it's going to work. But I believe that what happened here is that every sequential ping that it hit on this point was a different router that it returned back to. So we get 3 different line items for the 5th hop. So each try was a different router. You can see there's a different address for each time it went through with 3 different results. And then the last hop ends up being Google DNS, and that's the 3 averages for those times there. So that's how Traceroute basically does its work. And we can also do some lookups on these addresses and find out where they are as well, which is quite interesting. So we could go to an IP address lookup service and find out geographically where these places are. And then we can see actually where the routers are and where we can kind of bounce through. They're normally sort of indicative, though. They're not really exactly like a street level address. They're a rough area, so you can sort of see hops through countries and maybe cities rather than necessarily streets. So Ping and Traceroute are quite good applications, but someone came up with something a little bit better that combines both of those 2 things into one. It's called MTR. And MTR is quite a cool application because it allows you to do a bunch of different things with it in regards to ICMP. So we need to run MTR as sudo. So we'll go sudo MTR, and then we're going to provide it with an address as before. So we'll just use Google's address, Google's DNS servers, and it shows us some information about the host, the router along the path to get to the Google DNS server, but it also shows constantly updating numbers on the packet number, last, average, best, and some other data points in here we can see. So one of the cool things about this is we can also do something like press on Z, and it will show us the ASN, the AS number of the autonomous system of that particular router. So we can see that these servers here belong to one autonomous system, this another one. These routers are very much not going to be joined to an autonomous system. So this is our house router, and this is the building router. Once you get to the local area block router, that becomes a part of an autonomous system. It's very likely owned by a TPG. And then we go out to the US servers, I think are these ones here. So we can see a bit more about this if we press on Y. Y will show us a bit more data about the IP address info. So we can see the blocks that are associated with it on this. We can cycle through this as well. So we can do Y again, and it will show us a bit more information about the host country as well there. So we can see that those other ones are in the US. Y again will show us that one's Asia Pacific and one's ARIN. Y again, I'm not sure about the dates on that. And Y again goes back to the autonomous system. If we press N, we can also toggle some information about DNS to IP, so we can see the IP addresses versus the DNS address. And if we press J, we can see some more data about the jitter of the line. So this is really quite cool. If you're having problems connecting to something, you can really, really quickly work out what the thing is that's failing, because you'll be able to see that the packet drops will be like going up and up and up on the part of your route that's failing. So you might have a problem immediately at your local router, which would show you that your router's got a problem. Could be at the local building, could be at the local block, could be somewhere in the bunch of routers between you and the destination you want to get to. You can see all of that data here. It's a very nice application and very well put together. So I highly recommend you download this if you get the chance. It's MTR. Next up on the list of my recommended tools for using networking and whatnot is going to be Netcat. Now, Netcat is something that's seriously a nice piece of software. So first off the bat, what we're going to try out is how do we check if something on a remote server is available to us, if that remote server's application is listening on a port. So when I say listening, what I mean is the application on the remote server has been started, it's running, and it's available for other applications elsewhere on the internet or on that local network for that matter to be able to connect directly into that server. So how do we test that? We test that by using some kind of service that can use the correct protocol to go out and get to it. So obviously, if we're blocking ICMP traffic at the VPC, then we are not going to be able to use ping or traceroute to be able to access that server or even see if it's live on the internet. We've got to use something else. So a lot of people will recommend using Telnet, and Telnet is a great alternative to this, but I recommend that you use Netcat. It's quite easy to install. You can do it through Brew, or I'm pretty sure that Chocolati also has it for Windows. When we're using Netcat, what we're really doing is we're exposing the raw port, the TCP level, to other parts of the internet or other parts of your network. What we can do now is I want to show you how we can set up a sort of rudimentary chat application and then sort of demonstrate why we might want to use Netcat as one of our sort of favorite tools. So we can type in nc-l and then we can say the port number is 1234. What's implicit here is localhost. So if you don't specify an IP address, then it will just take it as the machine that I'm on now is the machine I want to create this listening port on. So then we can just go ahead and hit enter on that, and it's going to sit there and listen. So in another shell or another machine for that matter, what we can do now is we can say nc, and I want to put in localhost, and then I want to say 1234. And we're going to create a connection between those two ports in different shells here, but this could also be different machines if we were to use IP addresses here. It doesn't appear like anything's happened yet, but if we click into one of these shells, what we can do is we can type hi there, press enter, and you'll notice at the bottom in the other shell, it's passed through that data. And in the bottom shell, we can type hi, and it goes back in the top shell. So we can kind of see what's going on here is that there's a connection either side of this tunnel type situation, and whatever goes down one end comes out the other side, and whatever comes out the other side or goes in the other side comes out this side. Let's say we've got a file that we want to transfer across a port, and we want to be able to use any arbitrary port to do so. And let's also say, for argument's sake, we don't care about encryption at this point. What we can do is, let's say, create a text file. So I'm just going to vim my text file .txt, and then in here I'm going to press I to insert text, and I'm just going to write hello there, and then I'm going to escape :wq to quit, and that file now exists. So if this is my local computer, and let's say this is a shell of another computer somewhere else, what I can do here is I can set this computer up to listen to be sent a file. So I can do nc-l localhost, and then I can do 1234. So we're going to listen on that port. Now, the important thing next, though, is what we're going to do is we're going to say anything that comes across this port, we want to put inside of another file. And I'm just going to call this file.txt. And so the raw stream of data that comes through this tunnel, through this port, between these two connections, everything that comes in is going to go into this text file. So I'll just press enter on this. And this is just going to sit there and wait for an incoming connection. It's not going to do anything. It's just going to say, I'm listening on localhost. This could be an IP address or a specific interface on a specific port. And whatever comes across this interface, I'm going to put inside of this text file right here. So back on my machine, wherever this might be, I'm going to use Netcat, and then I'm going to specify an address, localhost, and I'm going to specify a port 1234, and I'm going to put into this interface my text.txt. So when I press enter on this, this will push all the data that's inside of this text file through this interface down the other side to the other shell and into that file.txt. And then it'll exit right away, which is quite cool. So now if I go back to this other shell and if I cat file.txt, it'll say hello there just as the other one did. And that's really handy. If we want to be able to test to see if a service is listening on another server, what we can use is the Netcat with a -vz, and we can go out and we can check the local host in this case, for example, and then we can check the port number of, say, 22 to see if SSH is listening. And we can see that connection to localhost port 22 succeeded. So for both output and Z means do not connect to the daemon. There may be times when you want to get the raw headers back from a website that you're troubleshooting or wanting to see what is being returned back from the remote server. One example might be with HTTP to see if what the headers are returning from a website that you might be trying to troubleshoot. So we can use echo in combination with Netcat to sort of get back the headers we're looking for. So echo is a bash command that we can use, and then we provide it with an argument, and it will just push that back out onto the shell. But we can also push that somewhere else with another application, and I can use something like echo, and we can use a -n. We'll open a quote, and we'll type in get / which is the path, and then we want to say HTTP 1.0, which is the type of protocol with a /r /n/r/n. We'll close the quotes, and then what we'll do is we'll pipe that into Netcat, and then we're going to send this to a specific web page that we want to be able to get the headers back from. And in my case, I'll just use my own website, so that's www.hamo.cloud, and then we've got to give it a port number, which is 443. So we'll press enter on that and see what it gives back to us. So we can see what it does return back to us is the website headers. And what we get in this case is a bad request from CloudFront. And the reason for that is because I've got security headers inserted in my my web page, so it won't allow this kind of access. And there's a body associated with that as well, a head and a body, and it says it's a bad request. This will only work from a web browser. But there are occasions where you could use this not just for web pages, but for other kinds of applications like mail servers. SSH, I think, also might be able to do something like this as well. So that's quite handy to be able to have in your back pocket as well. So the last thing we're going to do with Netcat in this section is we're going to try and do some remote execution using the tunnel here. So how we set this up is we go nc-l, and then we provide a socket or just the port. So we'll give a full socket here. So we'll go 192.168.1.149, and then on port 1234, and then we're going to pipe the results of whatever comes across that socket into bash. And we'll press enter on that. So now that's going to listen there and sit there until something connects to it. And then on this side, we're going to do nc 192.168.1.149 port 1234, and we'll press enter, and then the connection's then set up. So now what we can do is something like df, and we can see the result shows us the disk capacity of my current computer, and this will work across the internet provided you've got routing and no firewalls in the way. A note on this is really just sort of for illustrative purposes and why you don't want to really be allowing people to install random things on your machines, because this will totally circumnavigate all of your security. If you have any amount of ports open, that includes the ephemeral ports, which normally need to be open for traffic to work properly. So if you have ephemeral ports open and there's a route to the public internet, having Netcat able to be installed will give anyone who has access to this machine, or anyone who can install Netcat, the ability to set up a listener, and then someone can just connect right in. And this will work in both directions. So this doesn't have to be purely on the server side. Someone can set up the listener on their machine, get access to the machine, your machine that you've got, and then use the command line there to create a tunnel out of your machine back to theirs. And using some of the other tools we've used earlier, we can show you how we can transfer files out as well. So definitely worth knowing about. And now we'll move on to the next section. The next application we're going to talk about is curl, or CURL. And curl is particularly useful because it's installed on pretty much all Linux machines. and all Mac machines as well by default, so you haven't got to install this one. And it's a utility you can use to download a web page or the contents of a web page into your shell or into a file, and a whole boatload of other things too. It can also do usernames and passwords. It can go through proxies. You can set up a user agent. It can do loads of different protocols. So it does FTP, all these different things like that. You can deal with cookies. You can download things from FTP servers with authentication. You can resume downloads if something got interrupted for whatever reason. It has configuration files, and you can also output, rather than to the shell directly, you can output to a file. And we'll do a demonstration on that as well. So to begin with, we'll just try and curl a website. So we'll just go CURL, and then I'm going to do www.hamo.cloud. And that's going to return the exact output of what would be returned to any other web browser as well. The difference here is that that curl doesn't by default follow redirects. So if there's a redirect like there is here for 301, we want to follow that. So to remediate this, what we can do is we can use a -L, and then that will follow the redirect, and it will return the contents of the page. The raw HTML, what would be returned to the browser itself, not what you would see. So it's cool to be able to see all the data about what's going on here. And so if we go back to the beginning here, we can see everything that would be in the index.html page all the way down to the bottom of the closing HTML tag. So that's one thing we can do with it. So we can download a web page. The other thing we can do is we can download an actual file if we want to. So if we use curl and then we give it an address of a file that we want to download. For example, I've got the URL here for the Amazon CloudWatch logs agent, and I'm just going to paste this right here, and we'll see the output of this. So what's happening is it's going to go out to S3 and it's going to try and download that. I'm going to interrupt this right away. It's going to try and download the contents of that file, and it is downloading the contents of that file. The problem is that Bash doesn't know anything about how to read this raw binary data coming across the network. So this is just dumping in the entire file, the raw binary data of the file, into my shell, and it isn't saving it into a file. So this is basically not of any use to us. And what we need to do to make this useful is we need to change this slightly to add in a -O, and then we want to give it a file name like this is called the Amazon CloudWatch agent. And then we can click on, press enter on that. And then what we've got from curl is a really nice progress bar that shows us how we're doing with this. It'll show us how long it's going to take, how long we've been doing it for, the size of the file, all this really nice data about what's happening, so we can keep tabs on how well we're doing here. So this should be done any second now. Yeah, cool. And then it's there. So if I ls this Amazon CloudWatch agent, you can see that it's there. That's actually a PKG, so I can add the extension on the end of this, and it would be something I could install on my Mac if I wanted to, because it is the Mac version of the CloudWatch agent. So there is a similar application to curl called Wget, and Wget has a lot of the same features that curl has, but not as many of the functionalities that curl has. So Wget does offer recursive downloads over curl. Curl, though, has some nice magic where you can give it regular expressions where it can go and search out certain file names based on the regular expressions that you give it. But Wget by default will recursively download everything inside of a directory structure. Curl can do a whole bunch of things, like I mentioned in the last section. So FTP, FTPS, HTTP, HTTPS, SCP, SFTP, TFTP, Telnet, DICT, LDAP, LDAPs, file, POP3, IMAP, SMTP, RTMP, and RTSP. Whereas Wget only does HTTPS, HTTP, and FTP. Curl is more widely available than Wget. It compiles on more platforms than Wget. And curl can upload and send many different things, whereas Wget can only do a HTTP post to upload files. Wget will directly download files as is, and one of the nice things about Wget is exactly that. So we can do something like Wget, paste in your package that you want to download, press enter, and it will just go ahead and connect without any extra arguments, and it will download that file. In the same way, it's also got the ETA, it's got the transfer speed, and the file size as well is also given there. I'm not going to let that finish because we don't need to see that go through again. I'm just going to Control-C that, and that's Wget. The next tool we're going to discuss is going to be Netstat. So Netstat's quite a useful thing when you want to work out what applications are listening on whatever ports. So the way we use Netstat is we're going to do something like Netstat, and then if we just run Netstat by itself, it'll give us a bunch of output, which is kind of useful, but usually what we want to do is kind of filter that down a little bit. So what I might do is I'll give it the A flag, which is everything, show all output, but then I'm going to also put in T, which is going to give me all of the TCP ports. But then what I also want to do is I want to pass this to grep, which is general regular expression print. And I want to give that the search term listen, and I'll put that in quotes. And then if I run this one, it'll just take a minute to run the actual command, and then grep will filter through and look for the word listen. Grep will actually just return the whole line wherever that word appears. And we can see now from the output of that, we've got outputs from IPv6 and from IPv4. We can further filter down there if we need to. So what we can see is that SSH is listening on both IPv4 and IPv6, and we have a couple of other things that are listening here as well. What we can see on the right of this here, or in between listen and the service IP, is that it's listening locally on all addresses. So any interface where that comes in, it'll pick that up. So one of the interesting things about some of the Unix style commands that are used both on Linux and on Mac is that they're slightly different between operating systems. So the output of what you're going to see for Netstat on Mac versus what you're going to see on any other version of Linux varies quite a bit. Depending on the application, but Netstat does vary quite a bit. So normally with Netstat in Bash, if you do netstat-l, it'll show you the listening ports automatically without having to pass the output of this into grep, which is what this pipe thing does here. This pipe will take the output of this and put it into grep, and then grep will filter down on listen. But in Linux, it'll show you the listening ports, but in Mac, it does something else, and we can quickly investigate that with man netstat. And then if we just come down and look for -l, so print full IPv6 addresses. That's not particularly useful for us for our use case. But feel free to take a look through this manual page, and if you ever in any doubt of what to do, you can just on the machine you're on, you can normally just type in man followed by the command, and it will show you this nice manual page, and you can just press in Q to exit and go back to the start again. We will be covering this in a bit more detail shortly in another video on how to do some troubleshooting. So, and we'll also be doing that in Linux. Nmap is a really, really useful tool for working out what other hosts are on a network. You can also use it for scanning a specific host to work out what ports are open on that machine with pretty good resolution. So I've done a scan which is a -p scan on the router in my apartment, and you can see all of the open ports that are available on that router. I've done this already before I started the video because it does take quite some amount of time to get that done. So it's a few minutes to do a scan on a particular host, a detailed scan like that. But once again, we can go back to the man page and look at what some of the other things are available to us. And if we scroll down a little bit here, we can see there are going to be some examples. So there's SL, SN, PN, PS, PE, PO. All of these different scan types will give you a different kind of output, and some of the commands you might want to use here, you can also provide a CIDR block, and it will scan a group of hosts rather than just one host. It is worth getting familiar with Nmap, because it can really help you to work out some of your security holes, but also work out where things are on your network as well. If you're looking for a specific host, I think you can also give it a command that will show you the operating systems that are running, host names, and things of that nature. So it's a very handy tool to have in your pocket. There's lots and lots of people who have tried to make good Git demos, and I'm for sure not going to be able to make a very good one, but I'm going to have a run at it anyway. A lot of people tend to struggle with this, and I think it's worth my time to try to see if we can quickly go over how this works. So when it comes to Git, Git is a tool that allows you to track all of your changes, but also work in a collaborative way with team members or people who you want to work with on a coding project. It's very, very handy to have. And if you can understand how to use Git properly, you'll be a valuable member of your team. How does this magic work? So what we've got is Git is installed on my machine. I can see that there. If I type Git, it gives me some kind of output. I'll just clear that. And you can install that with Brew as well. So what I'm going to do in this empty folder on the right hand side, you can see this folder is totally empty. So what I'll do here is I'm going to do a git init, which is going to create me a repository. And you can see immediately we get this .git folder. Inside of here is kind of outside the scope of what you need to know about, but basically this is where all of the Git magic is stored for your repo. So this is now a repository, this folder, and it's scoped at the level of this folder. So if I add more folders into this folder here, that will also fall into the ability of this repo to track it. So what I'm going to do is I'm going to create a new file using touch, which is a bash command. It's going to go myfile.txt. So I've created a file, and we can see in my my bash prompt here that I've made one change. So we're out of this tick will mean that there's no changes to the repo, and this one means that there's changes here. So what I'm also going to do now is I'm going to vim that file, and I'm just going to type I to go to insert mode, and I'm going to type in hello world, because that's what everyone tends to do in these things. But so escape WQ, :WQ to quit. And then if I do git status, we can see I've got no commits. I'm on the master branch, and we have untracked files, and the untracked file is myfile.txt. So that's all good. So what we can do now to bring this file into the tracker of Git, so it's known by Git, and all the changes are going to be tracked by Git, is we do git add myfile.txt. So that adds it to what's called the stage. And the stage is like putting a spotlight on that file to say, hey Git, we care about this file when it comes to commit time. So if I do a commit, this file is in scope for that commit, and you can ignore everything else. So for example, if I did touch my other file.txt, I'll do git status, and we can see that my file is tracked. So where changes that are going to be committed if we do a git commit is my file.txt, and untracked files is my other file, meaning that if I do a commit right now, this file won't be included in that commit. which is what we're going to do. So I'm going to do git commit, and I'm going to give it a message with -m, and then I'll open some quotes up and I'll say initial. Normally you want to put in like a descriptive message in here, more than a couple of words, just to sort of be able to keep track of what each commit contains. It's a really good practice to get into, but for initial, it's just the initial, so we don't really care about that. I'll press enter, so we've got one file changed, and one insertion, meaning there's one line of text in that file that's been put in. So now if we do git status, we can see that my file is not in this list of things because there's no drift in it. There's no difference between what Git expects to see versus, and when I say expects to see, it's what Git is stored in this .git folder, and what's in myfile.txt is in sync. So Git's not going to complain about anything if I do a git status here when it comes to myfile.txt. When it comes to my other file.txt, it's in the Git folder, in the repos folder, but we haven't added it to the list of files to track, and we haven't committed it. So it says that, hey, this my other file.txt is not being tracked and not committed, and it's not going to be a part of what we care about. So when this gets uploaded to the remote, so for example, GitHub or GitLab or one of those types of remote servers, this file won't be included, even though it's here on the local. So that is sort of part of what we've got to understand to be able to be a useful member of a team. So the next part of it then would be you would like to do a git push, but you would also need an upstream, an origin to push to. So I'm not going to go too much into that right now because otherwise this will go on for too long. But basically, you want to push this to a remote, somewhere that other people could also potentially be able to download it and make changes to it themselves. So that's great. Now, once we've got a file tracked and we've been able to commit it and save it, and we've pushed it up to a remote, ordinarily if you clone down a repo from somewhere else, the upstream will already be implicit and understood, so you can just git push and it should just be fine. That's if we're on the master branch, which is what this lovely master word is here. It's telling us that we're on the master branch. On some of the newer servers that are out there, you get the master branch is called main. So main and master can be used sort of interchangeably. So we don't really want to be getting into the habit of committing and pushing changes to the master branch. So what we would generally want to do when it comes to making changes to your project or someone else's project, especially someone else's project, is you want to make a branch. So what we're going to do is git checkout -b, which means make me a new branch. And then I'm going to give it open quote. I'm going to say Thomas branch. And then it'll say switch to the new branch, Thomas branch. So now you can see we've gone from being on the master branch to being on Thomas branch. And if we do a git status, we can still see that the situation's the same as before. Now, if I do something like I want to edit my file, so if I use the Vim editor again and choose myfile.txt, and then if I do Shift A will take me to the end of the line and go in insert mode. I'll press return and I'll type in some change. Some change is good enough. And then I'll escape :WQ to save that. And if we do git status, we can see that I've modified my text file. So this is a change that's a drift between what's stored in the .git folder and what's in myfile.txt. So to be able to include this, what we want to do is we want to add this file. So we want to git add and the file name. And then if we do git status again, we'll be able to see that my file is now staged for commit. And if we do git commit with that file name.txt, it'll add it to the Thomas branch. So if I do git commit -m my new change. Press enter. If we do git status, we can see that the commit removes the error message, but once again, the commit is only local at this point until we push it up to a remote branch. Like I say, I don't have a remote branch for this because I literally just initted this on my local computer. But what you would normally do is at this point, you would push your changes back up to your remote Git server, whether that's GitHub or GitLab or wherever else. So what's interesting about this now is we've got two separate branches. So if I do git branch -a, will show me all the branches. I've got a master branch and a Thomas branch, and the star shows me that I'm on the Thomas branch. But also on git bash, we can see that my branch is actually shown to me here. If you're using regular vanilla bash, this won't be shown. So if I move back to the master branch, git checkout master, and then go git status, we can see everything's still more or less fine. But if I vim the myfile.txt, that change that I made before doesn't exist in this branch. It only exists in the other branch. So to really illustrate this again, if I go back to git checkout Thomas branch, oops, and then we can still see that the file is still here on the side here. But if I do something like git rm myfile.txt, we can see that this file's been removed, including in Git. So if I do git status, I've deleted the file. Now I want to do something like git add my file. Oh, sorry, that's already done. So I want to do git commit -m removed file. Okay, so that's now set, and that file's been removed in my Thomas branch. But if I git checkout master, the file comes back again immediately on the side here. So this is a global scoped thing. So if you check out a branch in Git in Bash, it affects the file system. This isn't just something that affects the shell alone. So if you check out something in your shell, in VS Code and in the file system, the files will be affected in real time, depending on the branch that you're on. And it's really important that you understand this. So do take some time to have a play with this and have a mess around with it. See if you can wrap your head around it. Now, if you want to download someone else's branch from GitHub, for example, all you've got to do is go to the website, github.com, search for the repo you want to download. Maybe you've got your own repos that you've got there. And what you would do is something like git clone, and then you would paste in the URL that you would get from the pasty chart thing that is on the repo's main page. So then you would just paste in that URL here, and if you've got the right credentials, you'll just be able to download that directly. Without getting too far into the weeds on this, what I want to do now is I want to show you what it would look like once you've cloned down a repo. I've got this mytf folder that I've got on my own GitHub, and you can find this online. I've changed directory into this mytf folder, and I'm on the master branch. So what we're going to do at this point is we're going to quickly try and walk through what it would look like to edit some production code for some project that you're working on in a way that would look like it would be done in real life at a company, for example. So I would clone down the repo where I'd got it from, or if I already had the repo locally from working on it beforehand, I would do a git pull to make sure I got the local, the most up-to-date local version. So it says already up to date. So I've not made any changes to this repo since I've downloaded this, which is a great sign. So I can see that there, already up to date. So at this point, what I want to do is make a new branch for myself. So I'll do git checkout -b, and then I'll give my branch a new name. So I'm just going to say testing, but you would call this something meaningful, whatever that might be for your particular use case. Oftentimes, what you'll also want to do here is tie this back in with a ticket number. So, for example, a Jira ticket or something of that nature might be called for here, and there is some automation you can get which will allow Git to scrape up the ticket ID and then match that back with your Jira ticket directly. So create a new branch with the -b. So we've changed the testing branch. We can see that in the prompt. And then what I might do is open up VS Code. So I've got VS Code open here, and you can see that I've got the exact same thing that's in the file system is also present here in the mytf folder as well. So I can come into here and I can choose any file that I want to make any changes to, which is all under the scope of this mytf. And then I can say, for this example, I'm just going to maybe go to the readme.md, and doing something as simple as making a new line is going to show us on the left side here a green bar. And this green bar is going to show us, if we click on it, what the change was. So Git's basically going to show us line by line differences for things. So a new line is going to be a difference, and I'm just going to leave that as it is. And so there's no significant change, but there is a change here for sure. So if I do a save on this, so I'll save that file, the white dot disappears, I'll close that. We can see that this has been modified with an M, and I'm going to go straight back to bash here, and I'm going to say git status, and we can see the modified tag is next to the readme.md. So I'm going to do git add readme.md. If we do a quick git status, we can see that it's gone from being red to green, meaning it's staged and ready for commit. So if we do git commit -m update readme for demo, and that's done. So we've got that all back in sync on the testing branch. If we were to go back to the master branch, of course, that would still be without that extra line because it's a whole different branch. And so what we're going to do now is I'm just going to git push. And what happens here is when you're on a branch that doesn't yet exist on the origin, it's going to give you this kind of error message here, but it's a really helpful one because what you can do is you can just basically just copy this whole thing, Control C, Control V. Actually, I might just, Control C, Control V, and paste that in. And what this is going to do, it's going to git push, set the upstream origin to the branch called testing. And we press enter, and it goes out to the GitHub server, and it uploads that new branch. You can see here it's a new branch, testing on the remote. The other cool thing is here, this is the URL we want to go to if we want to create a new merge request. So I can just right click and open the URL, and that's going to jump open the pull request page, and then it's going to show us that there's no conflict, so we're able to merge this. We're going to merge into the master branch from the testing branch, and then I'm just going to say create pull request. We can put in some more details there if you want to. Does its checks. So on my repo, I actually have a CI file that will go through and run some pipelines. So we won't be able to merge this until those pipelines are complete. So while we're waiting on that, I'm just going to pause the video. So because this branch does have a number of jobs associated with the pipeline, and I do have some gates in here that won't allow applies to occur until I've actually gone in and double checked that everything is as I want it. So I'm just going to illustrate that quickly what's going on here. So the pipeline itself will be invoked when you try to merge into the master branch. So we are trying to merge into the master branch now. So there's some linting checks that are being done. So that's in this part right here. There's the linting job is the first one, and that was successful quickly. And then there's 3 plans. So there's a plan on each of my Terraform deployments, and those plans are then sort of gated. So I've got to go in and double check what they look like. And this will just wait here until I've gone in to approve each of those branches to be deployed, or each of those jobs to be deployed. So what I'm going to do is I'm going to right click on show here. Can I? No, I've just got to show environments. Okay, cool. If I open this in a new tab, yeah, so if I open up this review deployments tab here, we've got 3 jobs that are outstanding. So I've got to basically approve these. But before I do that, I actually really want to make sure that the plans themselves don't cause any change. So I can come in here and look at the plan, and open up this plan here and roll down. You can see that Terraform was initialized and there's no changes on my website. I'll go to one of the other websites here, which shouldn't have any changes either. This is actually no changes despite this showing some change here. It's just the order in which they're presented, but it does say no changes. There's no updates going to be applied. And then for my VPC, the Terraform there should be the same story more or less. One to change, which is on a default network ACL. It's going to add an empty name. Add a name tag. Okay, that's fine, and I'm going to just allow that to go. So if I scroll back up to the summary and then go back to the review deployments, I'm just going to go ahead and ungate each of those 3 deployments, approve and deploy, and then we'll see that each of these apply stages will then get kicked off based on the whatever's in the plans. And basically the applies will do a plan again, and then they'll auto approve and then deploy. So we can see that those are actually deploying here. If we come back to the merge request, I believe this should also update as we go, but it doesn't seem to be doing it live. But that's fine. If we go back to the pipeline screen here, we can see that each of these are in progress. They are running. 2 of them will do basically nothing, and 1 of them will add a name tag. So very nice diffs that comes out of Terraform there. Usually this will take approximately the same time as the plan will, provided there's no actual changes, because it really is just rerunning a plan. Okay, so that's each of the applies are complete. We've got 3 green ticks that show us that that's all completed without error after 5 minutes 49 seconds. So I'll close out the pipeline screen, and we can see that all checks have passed, and we're going to merge the pull request, confirm the merge. So the pipelines have all passed, and the branches have been merged together. And also, we've deleted the testing branch. So that other branch for testing has now been removed. So if we go back to the shell, and if I do git checkout master, git pull, and then if I do git branch -a, we can now see that the testing branch is still there. But yeah, so the branch has been removed on the remote server. So if we go back to the code and then look at the branches here, we can see there's no testing branch in here. So testing is gone on the remote, but it is still present on my local at this point in time when I'm free to remove that branch. So hopefully that has helped to clear up any questions or interest you might have in understanding how that works. The AWS CLI is a really, really important tool to understand how to use when it comes to using AWS. This tool is heavily referenced in the documentation. There's heaps of information about how to use it. So I really recommend that you make some time to get familiar with this as well. So to be able to use the AWS CLI, you can really just type in AWS commands right into the shell. But as I might have, as I mentioned earlier on in another video, we don't want to just be able to run AWS CLI commands against like the normal bash shell when you just open it up. We want to have to give the shell an explicit profile to use, which is allocated to an account, a direct account, a specific account that we can't accidentally do to another one. So if I was to do AWS S3 LS right now, it's going to fail, and it's going to fail for good reason because there's no credentials associated with the default profile. So I've got a default profile, but it doesn't have any access keys or secret access keys available for use with it. So I'm going to go back to using my Thomas credentials, even though I've had to put in new access keys for that since I rotated those since the last demo. The way we do that in Bash is we export capital letters AWS_profile equals, and then your profile name. And then to test that this works, we can do AWS STS get dash caller dash identity, and that should return back to me the identity that I'm using for this particular profile, and that works. So we can see that my user ID is here, the account ID is here, and the ARN for the user that I'm using is here as well. So that's quite handy that we can see that this is all working now. So now that if I do that same other command again, where I do AWS S3LS, it's going to actually return me all the buckets that I've got on my account. So that's really nice. So how does all of this work exactly? So AWS is the binary that we're referencing, which is in the binary folder, and then which is also in our path. So what we're going to do then is we're going to give it an argument. So we're going to say which service we want to use. So that could be S3, could be EC2. Every single service is available for us to use here. So normally there'll be a service and then a verb. So what are we going to do? S3 and then LS is the thing we want to do to S3. And that will go out and grab the buckets. Or we can do AWS EC2 describe instances. And that should also go out and describe all the instances that are there. What we can see here, though, is if we don't give it a region, because this will work with S3 without any problems because S3 is a global service. But when it comes to using services that aren't global, we normally have to give it a command reference for the region. That looks like -- region. And then we just say AP Southeast 2, that's Sydney. And that should work. Yeah, that's worked. Great. So what we can see here, though, is it just shows a JSON object, but it's got reservations, which is the top level of the EC2 structure. Inside of reservations will normally be some instances, but if you don't have any instances, it'll just be an empty list. So this square brackets is a list. So that's quite handy. So we also can do man AWS CLI. No. What about AWS help? So AWS EC2. Yeah, okay. So this is the man page for AWS CLI, and there's going to be a bunch of options in here that you might find useful, so we can give it different outputs from the... So normally we get a JSON output. We can change the output from JSON to text to table, YAML, YAML stream. And then we've got the main important things, which is query and filter is the other one that we care about for the most part. So query lets us specify a certain set of queries, and then filter lets us take the result of that query and then return us back the bits and pieces we really care about. We can override the profile directly from the CLI by giving that explicitly at the command rather than giving it as an environment variable. The region we've just covered, and we can also find the version by typing -- version. So then we can just basically roll down through the help file and we can see all the services we can access. So all of these services are going to have the ability for us to interact with the CLI, interact with that service via the CLI. So all that stuff is going to be available to us here, and we can get some quite detailed information about each of those things. It's very, very handy to have. So there isn't really much point in going into too much depth at this point, but it's important just to understand that it's simple as AWS service name and then the verb of what you want to do to the thing. And so that could also be something like AWS S3 CP, and then we can give it an S3 path and a bucket name, and then a file name .ext, whatever that might be. And then we can give it a local path, which could even just be as simple as dot, meaning this folder. So I could copy a folder or a file out of S3 to my local, the directory that I'm in now, or I could even give it a relative path of projects, for example, and that would also be fine. So that there would work to copy files out of a bucket to your local machine, or even you could also copy to another S3 bucket in this way as well, so that you could then transfer between buckets from the CLI. So I hope that gives you some kind of good insight as to how this works.